we'll be talking about the types of discontinuity.
The 3 major types of discontinuities. Questions, please?
First, what is the continuous function?
It is predictable and goes on forever. Oh,
Next question.
All right. Next question. What are the 2 families of discontinuities and why are they in 2 families?
The 2 families are removable discontinuities and non-removable discontinuities. They are in different families, so you can identify each of them. Next question.
What are the 4 types of discontinuities?
The first one is a point discontinuity. It has a hole, and sometimes it has a point above of the hole. And the other one is jump discontinuity, which is a graph snapped by a point. No.
Oscillating behavior. It is a wiggly that is smushed together in the center. Infinite has a vertical asymptote and it decreases or increases without a bound. And in the next clip, you will see these types of discontinuities. We see the point discontinuity, the jump discontinuity, the oscillating behavior discontinuity, and the infinite discontinuity. And if you memorize all these, you'll be set.
As the limit approaches from the left side, it has to get closer to 3, so it's 2.9, 2.99, 2.999, and so on. The same for coming from the right side, which would be 3.01, 3.01, and 3.1. The way you would say it is the limit as x approaches x squared minus 9 over x minus 3 equals 6. The limit in this equation can't be reached because f at 3 does not equal 6.
A limit is an intended height of the function. And this is the equation. To read this equation, you gotta say the limit as x approaches a number of f of x is equal to L. Okay. Sometimes the value of the limit is just approached, meaning the graph never actually reaches it. However, the continuous functions, the value of the limit can't be reached. The value of the function is not necessarily the value of the limit.
When solving limits graphically, you have to plug f of x into your white screen. Option 1 is to go to table set and make your independent variable ask, and go to the table, type in variables close to the limit you want to evaluate. Next, for option 2, you have to go to the graph, hit trace to the value you are looking for. For instance, here you see that it is not defined, and here it does not exist because there's a point and a hole. For this one, in the graph, we see that when x is negative 3, x equals 2. When x is negative 1, f of x is 0.
So the limit does not exist because the points do not meet from left and right. Because this one, for infinite, because it has a vertical asymptote and it's unbounded behavior. And then for oscillating, because it's wiggly and we cannot find the exact point.
The direct substitution method is when you plug in whatever the limit is into the equation, and if your answer is a number, then you're done. If it's 0 over a number, then the answer is 0, you're done. If it's a number over 0, it's undefined and the limit does not exist, again, you're done. And if it's 0 over 0, it's intermediate form, and we use another method.
So if it's 0 over 0 and you get the indeterminate form, you use another method. You use the conjugate method. Alright, when using conjugates with limits, we sometimes use a conjugate of denominator. Other times, we use a conjugate of a numerator. And this will help us find the limit.
A continuity is predictable and goes on forever. A discontinuity is when there's a limit. And remember that a limit is intended height of a function and a value is the actual height. And if you remember these things, you'll be set. Thank you. And look at us, we follow the rules. Don't we look happy? Bye and good luck next year.